Welcome to Hot Topics. Today's subject will be multi-wire circuits. Quite a few questions come in about what is a multi-wire circuit. Is it one ungrounded hot conductor? Is it two hot conductors with a neutral? Three hot conductors with a neutral? Or as just pointed out, one hot conductor with a neutral? So first of all, before we really get into these details, let's go over to page 33 in your code book if you have it handy. And let's take a look at page 33. And on the left-hand side of page 33, down toward the very bottom of the column, we pick up branch circuit multi-wire. And it reads, a branch circuit that consists of two or more ungrounded conductors that have a voltage between them and a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit, and that is connected to the neutral or grounded conductor of the system. And then, of course, you can define what a grounded conductor is. That's usually, a corner grounded, where you take ungrounded conductor and ground it, or a neutral as defined in Article 100. Now, one of the things that people get confused about, let's go over to page 118 now of your code book. If you got it handy, just bear with me here. And let's go over to page 118 and look at the section that is given a problem for a good while. And we want to look at 250.32A exception. On the left-hand side of page 118, down toward the bottom, of the first column, we pick up the exception. And it says a grounded conductor shall not be required where only a single branch circuit, including now a multi-wire circuit, supplies the building or structure, and the branch circuit includes an equipment grounding conductor for grounding the non-current metal parts of the equipment. Now this is until we added a multi-wire circuit. They just said a branch circuit, and some folks said, well, now that a branch circuit, that's just one hot ungrounded conductor and a neutral. And that gave a lot of problems. We put the multi-wire circuit in, and they still thought it was just one ungrounded hot conductor along with one neutral. So we added multi-wire circuit there a good while back in the NEC, and then we added it into the definition, which we just read there on page 33. Now, 210.4 in the 1975 code was revised to meet more commercial type installations. And it said, well, you had to disconnect the all ungrounded conductors in a multi-wire circuit so that you didn't get between the neutral. So that was a problem, and in the 1975 code, we revised 210.4 to add that information in so that electrician would know that, for example, if we'll review the figure 12-2 in Stallcup's electrical design book, volume 1, and show that, we would kind of pigtail, in other words, splice the neutral together and pigtail it, which we call a bonding jumper. And that way, when you removed a receptacle or fixture, whatever it may be the case, you wouldn't be removing and breaking the continuity of the neutral conductor. This was where a problem came in. But it was only for a situation where you might have a receptacle, and you took the receptacle and you broke the link from the top of the receptacle duplex to the bottom. You brought an ungrounded L1 to the top, an ungrounded L2 to the bottom, and it shared a neutral. But until this revision took place, electrician would go in and take a voltage reading on the top of the receptacle and get a reading, go and shut the breaker off, go back and hit it, not realizing that L2 was still hot and that neutral conductor was sharing a load downstream, maybe, see. They accidentally get between it, they receive a pretty bad shock and sometimes even a fatal shock. So in the 1984 edition of the code, we inserted a 300.13b as in boy. And we basically said, in paraphrasing that particular section, that you had to pigtail and splice the neutral. And when I say pigtail, that's just a bonding jumper. So that if you removed a fixture or receptacle that was a multi-wire circuit, you didn't break the continuity of the neutral and you prevented somebody getting between it. But there were so many electricians that still connected these circuits in the old way and used the receptacle to break the neutral instead of splicing it and putting a bonding jumper on it and connecting it so that you wouldn't break that neutral continuity, removing a fixture or receptacle, for example. So in the 1984 code, we added 300.13b. But then we came along in the 2014 NEC and added another safety factor that kind of lined up with what 70E would want you to do. We said you'd use a double pole breaker if you say on two HOTS, ungrounded conductors with a neutral, double pole breaker, or two single pole breakers with handle ties that met 220.15 of the NEC. Now, we know that 220.15 says, oh yeah, these handle ties have to be identified and approved and so forth to actually serve to connect the two single pole breakers together, so you disconnected both, and now there wasn't any danger by disconnecting both of those. You broke both of the ungrounded circuits, or three-pole breaker where you break three of those ungrounded circuits where you were sharing neutrals. Now this was a really tremendously bad problem in commercial, where we would say have a 208 volt, 120 volt system, and we would take L1, L2, and L3 and share a neutral. And we would take L1, maybe put 10 outlets on it, take L2, 10 outlets, L3, 10 outlets, sharing one neutral. So in the 1984 code, we said, all right, and under those conditions, we had a multi-wire circuit, you would splice the neutral together and put a bonding jumper on it where you wouldn't break the continuity, see. But in 210.4, there was a revision that took place, and if you'll move over, we'll take a look at that around page 60 maybe. Let's try page 60, and I think that would be okay. And on page 60 of the NEC, on the right-hand side of the page, at the very top of the second column there, multi-wire branch circuits is our title head. A, we pick up the general rules. B as in boy, we pick up the disconnecting rules, which might be a double pole breaker, three pole breaker, single pole breaker with approved handle ties in accordance with 220.15B1, I think it is, and that would be on approximately page 101, I think, of the code. Now, C part deals with line-to-line load, line-to-neutral load, excuse me. Those are the only loads that a multi-wire circuit would be considered approved to supply is line to neutral loads. And then D part was added in 2014 that said, hey, grouping is required. Now, for example, if you had in a raceway, if you had, say, 277 480 or 120 208, but say that you had 3 120 volt circuits with a neutral, 3 more 120 volt circuits with a neutral, then you would know which neutral went with which pair of L1, L2, or L3s. So you would identify the neutral with L1, L2, or L3. The second neutral, you'd identify it and group it with L1, 2, or 3, and then make a note of that back at your overcurrent device. The only time that you wouldn't group is if it was evident that, you only had 3 hots and 1 neutral. In that case, you wouldn't have to group. Now, when you run these multi-wire circuits, I suggest that you look at 210.4 A through D. You would also want to review 210.7. And then you would want to look at 240. I think is the section you want to look at, not 220, but 240.15 B1 on page 101. I think I misquoted that. I think I told you 220.15 B1, but it's 240.20 or 240.15 B1. Getting a little confused myself here. We've had so many revisions and changes to this section. Some of you know the 71 code was the first code that I ever worked on. And NECA and IBEW appointed me to serve on subcommittees. I wasn't on the main committee or panel, but I was on subcommittees. And we were putting industrial articles into the code. And it wasn't until the 1981 code that we really finished and put enough articles in pertaining to industrial and commercial locations that OSHA said, okay, we can go with that, and then we'll add them as we go along. More articles where it becomes necessary. But look at those sections, and I think you'll come up with a good amount of good design and installation. Engineers, you should be very careful if you're designing multi-wire branch circuits to make sure you inform the installer to enforce 300.13b by splicing the neutral and putting a binding jumper on it, and also the double pole or 3-pole or single pole breakers with handle ties for multi-wire circuits, and then review very carefully 210.4 A through D as in dog, and 210.7 along with 240.15 B1, and I think that would give you enough information that you don't have to worry about somebody getting shocked severely, or maybe even getting maybe even a fatality happening, and somebody coming back wanting to sue you. Electricians, if you're out on the job and maybe an engineer forgot to put that in, those rules, call the engineer, get a addendum sent out, or get the approval of the engineer to go ahead and do that. Don't put it in wrong. The NEC is just a tool to electricians, just like your screwdriver and your clients. It's a tool. You have to know it to be a top-notch electrician. Go through the code and just look at the articles that deal with the work that you do. For example, if you run a non-metallic sheet cable, which we call rope, we'll call it Romex, we'll go to Article 334 and just read that little short article on it so you know all about it. If you're running AC cable, MC cable, do the same. If you put in a lot of non-metallic conduit, then go to those articles that are listed in the table of contents. Right at the front of the code, I think it starts around page 4, somewhere in there. You can look all those up and just highlight the articles that deal with the work that you do and just read those. And then you'll find the more you read, the more knowledgeable you'll come on how to apply the code to any installation that you're going to make, because you'll know how to go to the table of contents and look up that particular subject dealing with your installation. Engineers, they do the same, and inspectors, also do the same. It's just that inspectors, they pretty well have to know all the code that deals with the work they do. If I'm just a residential inspector, then I want to know the residential code, dwelling code by ICC. I would want to know the NEC. that deals with dwelling units. If you do a lot of commercial work, with the same thing, or industrial, whatever it may be. But now, these are sections that I suggest that you review very careful. Now, looking at the illustration 12.-2, I believe it is, it's in Stallcup's Volume 1 design book. We pick up 314.16b, and like I say, I believe it's figure 12-2, and that particular illustration shows the neutral being spliced with a bonding jumper on it. And it has other important information there that's important to the installer, but you notice sometimes, people say, your illustrations are kind of busy, but we do try to give you all the information that you need in an illustration to complete your loop, so that you know exactly what's going on. But when you review that illustration, you see you have two hots coming in. And those two hots come in, and the other side of this receptacle that you see in the illustration, the link between the top receptacle and the bottom's been broken. But for the neutral, no, it hasn't been. It hasn't been broken. So if I don't pigtail or put a bonding jumper on it, and you see both of those neutrals coming out there connect to that silver brassy terminal there, once I remove that receptacle, I broke that neutral. And the other hot coming in there is still trying to complete a circuit. So you don't want to complete that circuit by getting hold of both of those neutrals and letting that current flow from arm to arm and through the heart area, where it could be very damaging. So we want to show you that illustration. Now, the next illustration we review is means of identifying the grounded conductor. And you notice we have 480 in the illustration. Now, this is an illustration 200.6A1 through A6 that comes from our 2020 code change book. But notice you have 482.77 coming in, routed in conduit over to a pull box, junction box. And then you have a feeder going over to a transformer. And you're tapping off the secondary side of that transformer with transformer secondary conductors. And we have 122.08. That's routed up to that box, and they're mixed. So we identify the neutral with the 480 and the neutral with a 208 volt soon. And then, of course, you come back to the grounded portion, and you identify in the panel board the circuit mapping, 408.4. So it ties in with this 210.5A through G. And then, of course, if you want to see, for the grounded conductor, we can go to Article 100, 200.3, and 200.10b, and we can pick up, those are pages about 36 and 58. You can pick up definitions that will define these conductors if need be. But notice you have all this information here. Simply, it's means of identification of the grounded conductor, where you have different voltages, such as 482.77 and 122.08 with neutral connections there. And that's one of the things that we really wanted to make sure that we would do, is to design that in that manner. Now, the next illustration that we'll want to look at here also comes from Stallcup's illustrated code change book, and it gives you the means of identifying the grounded conductor still. But notice you may have, you may have a situation where you're adding a circuit. Maybe you have a 122.08, you're adding 482.77, and you would only have to identify the new circuit you pulled in. You wouldn't have to identify the existing circuit without you just wanted to do so. And that's what this section's, trying to relate the information to you on how to do that. And of course, you see in the illustration 200.4b that deals with identification. You come down with a raceway and the circuits in it. That's 12208, the 480 volt 277. You have those circuits in the raceway that you see in the illustration with the top call out information that's right next to the weatherhead pointing toward that raceway. You have the identification in the panel board listed there in 210.5A through C. And notice, if you really wanted to look at where insulation, certain types of insulation is used for wet, damp, dry, insulation exposed to the sun, the identification and the color coding, always remember 310.6 on page 155. 310.10 on page 156. All these sections I've been giving you, they refer you right to those sections. So 300.10 is going to refer you to the identification or color coding of conductors. So we give you all that information. And for the grounded conductor again, you can go to Article 100 and define it, 200.3 and 200.10b. Pages 56 and 58 will get you in the code book to those areas. And you can review this in more detail to see just exactly, what has taken place. But the main thing is the 1975 NEC, the 1984 NEC, and the 2014 NEC. And if you review this information in these sections that I gave you, then I think that's it in a nutshell. That's kind of the end of the story, so to speak. And this has been, our topics that we are going to cover today, hot topics.